All right, where are we? Okay, next up is Juan Carlos Martinez Oliveros. And by the way, Amir, yes, your presentation is now here. All right, and Juan Carlos is from UC Berkeley. Welcome, and he's going to talk about Eclipse Megamovie 2024. Off you go.
Well, thank you, and good afternoon, everybody. I am not as eloquent as Gordon is, so I'm sorry. So I'm going to talk about the Eclipse Megamovie 2024, what we did this year, what was different to the last one, and some updates on where we are at the moment. This is not my job. I'm talking on behalf of all this team, and this team is also the citizen scientists that are actually doing the work. I am doing nothing. So, that's a good thing, right? So the Eclipse Megamovie project is an effort to engage the citizen scientists, the community, to do photo documentation, processing, and analysis of the 2024 Eclipse data. And we are going to use them also for the 2017 data. Our science objective in this case is just to explore and characterize transit plasma flows and CMEs stuff and things that happen in the sun during the eclipse. The project is also to demonstrate the power of citizen scientists in our field of solar physics, and how people without a scientific background or astronomy background can actually do a lot of work that it will benefit us. So the Megamovie, as it says, and it was defined by Hugh Hudson, is the same as this movie from 18-something. That is a bunch of still images, doesn't give you any information about that horse and how it is moving, but if you stitch them together, then you can have something that is moving and is showing you exactly how the horse is moving and maybe how the person is going to fall. So how we did this year? Well, we had not thousands and thousands and thousands of volunteers like in the 2017. We learned our lesson and we went to 125. Because it was really, really hard with thousands of people giving us images. So we had 125 core volunteers. For them, we developed a better tool on how to teach them what exactly we needed to analyze the data, and particularly to take dark frames, flat fields, the light data, bias, and how combine them in such a way that you can calibrate the data. The other thing that we made different this time is that we asked all of them to report that they have similar optical systems. So there was a gold standard defined by the team, and they needed to follow those requirements. We 3D printed mounts, because this time I didn't want to spend all my life trying to correct all the motion of the sun and in the frames. So we have 118 3D printed tracking mounts made by Sonoma State. We ship them to them for free. I don't know what they are doing with those track mounts, but they're doing something. So far, we received the images and the data sets for 125 of the volunteers, plus another 3 people that I don't know where they came from, but but we have that data. The total volunteers that we have are actually more than 125. There are about 500 volunteers that are going to help us in the analysis of the data using different tools. One of them is Kaggle competitions, so that they can compete between each other who created the best image of ever. This is a map showing the locations as the survey that they made report. So you can see in the right that actually they are most in the path. But some people did not understand that when we ask for location, we are asking them to tell us where they were, not where they are. So you have people in California or British Columbia that yes. The people in Alaska is actually the people that didn't give us any position. But in the data, we have the GPS location of the camera. So that's fine, it's not bad. We have here the instrumentation that they gave us. We can make a shout out to Canon. People here in this country love Canon. And they also took pictures of their setups and things like that, and that's the reason why you see a lot of phones and iPhones and Google Pixel phones and things like that. The pipeline for this year, for this Megamovie, it's pretty much the same as 2017. We have the database at UC Berkeley. The calibration is the first step. Now that we have all the darks and flats and bias, we can calibrate the data. The second one is to co-align, because not all the tracks, not all the people were pointing exactly to the North Pole. So you see a drift, a small drift. So you need to co-align them. And then we are going to use the calibrated images to start the rotations. And here is where the team has a bunch of discussions on what exactly we are going to be using for this rotation, either the poles, the streamers in the poles, or we are going to use the prominences that we see in the chromosphere, what exactly we are going to be using. The next step is to generate HDR images for each site, which we are down like 40% because most of the people were in Texas. That's good for me. I mean, it's less data, right? We have students also working on this in Sonoma State. What they are doing is the software that determines which image is actually in totality and which are not, and they are using two different techniques using machine learning. One is using a neural network, and the other one is using something called the back of words. Since I'm not a computer scientist, I have no idea what it is, but they are doing it, and they have some results. They have been playing with the 2017 data. Then we have here that we are still working on our HDR imaging. So these are 2017 data. So it kind of looks better than the last time I presented this. And the images from this year are looking like this. So the volunteers are actually there working on this. Yeah. I don't know. They are not rotated and everything. They are artistic pictures. Right, and then you have another one, for example, for Nate Eaton, or you have already compositions made by other people, like this one, where you can see the image from the eclipse in the middle. And this was with Santiago Vargas. And I'm going to end here with this one because the image of the corona is mine, so I like it.
Thank you very much. Time for a question or two. My question is, I remember in 2017 I participated because I was on the ground as opposed to on a ship, and I had an equatorial mount, but I know a lot of people didn't, and that's really gave you a lot of headaches, right? Yep. So you still have to make minor adjustments at least because not everybody got perfectly well polar aligned. Did you give them tips for how to polar align in the daytime and all of that?
Yeah, so we did have, we had a lot of training for these volunteers. We had trainings with the moon, trainings with the sun, with filters, and so they didn't know how to use it, but
yeah. Well, there's always a little bit of plus or minus. Okay, great.
Yes, just the obvious question: when will the end product be available, and how will we know when and where to find it?
So all this data is going to be public eventually. As soon as we calibrate it, it is going to be open at the UC Berkeley website, at the Space Science Lab, I should say, or the Berkeley one.
Great. Do you have an idea of approximately when that will be?
That's it is TBD.
Okay, TBD.
TBD.
All right. Sounds good. Let's thank Juan Carlos again.